So this question says that we have a sinusoidal water wave generating in a large ripple tank. So if I were to look at the side of this, we're going to have a sinusoidal wave in a large ripple tank. And it's going to say that the adjacent crests from one to the other are 5 centimeters apart. And that this wave is traveling with a velocity of 20 centimeters per second. And it wants to know what's the time required for a whole new cycle. Well, I know that to get a whole new cycle, that this is equal to 1 period. So I'm going to use the capital letter T for what we're trying to find. So we're trying to find 1 period. They gave me position information and velocity information. So in my graph, I have the height of the wave versus the location of the wave at some time. And I'm going to say it's time equals 0 because I decided to start with a sine function at 0 equaling 0. So I need some additional information for this. Well, I know that the velocity of a wave is equal to the wavelength of the wave times the frequency of the wave. Which I have the velocity, I have the wavelength. I don't want the frequency, I want the period. But I also know that the period is equal to 1 over the frequency, which means that the velocity of the wave is equal to lambda times 1 over the period. Or this can be rewritten as the period of the wave is equal to the wavelength divided by the velocity. So in this case, our wavelength was 5 centimeters, and our velocity was 20 centimeters, which should give us 1/4, it's centimeters per second, gives us 1/4, and we'll see that the centimeters cancel out and the seconds are left. So we get 1/4 of a second, or 0.25 seconds is the answer. So we can use the velocity information to relate the period and the frequency of the period and, the period and the wavelength, or the frequency and the wavelength. So this is the more general equation that we see or we use more often. It shows up a lot of times in physics, but this was the one that we wanted to use. So just making a simple substitution.